Welcome, everyone. Today, we're diving into an important concept in C++, namespaces, and understanding why they matter so much in real-world programming. In large projects, we often use functions and variables with the same names. Without namespaces, this leads to naming conflicts, making our code harder to manage. But that's not the only problem. Without proper organization, the global scope gets cluttered, increasing the risk of accidental overwrites and confusion. When working with multiple libraries, we can group all these issues under the umbrella of namespace problems. This further can be classified into two main categories: name conflicts and beyond name conflicts. Under name conflicts, we'll see functions, variables, or classes with the same name clash across files or libraries, causing compiler errors or linker errors. Under beyond name conflicts, we'll discuss issues like code ambiguity and readability issues, increased risk of accidental overwrites, difficulty in maintaining large-scale projects, global scope pollution, confusion with standard library functions, and dependency confusion between libraries. To make things even better, we'll also explore some powerful namespace features: nested namespaces for super-organized code, namespace aliases to simplify those long names, unnamed namespaces for file-specific scope, inline namespaces for smooth versioning, Koenig lookup for smart function call resolution. Let's get started with name conflicts. As C++ programs grow and integrate multiple libraries, name conflicts can become a serious challenge. This happens when different parts of the program define variables, functions, or classes with the same name, leading to ambiguity and errors. This is one of the key namespace problems in C++. To better understand these conflicts, we can classify them into two main cases. Case 1. Conflicts that result in a compiler error. Case 2. Conflicts that lead to a linker error. Let's begin by exploring Case 1, where naming conflicts cause compiler errors. In Case 1, consider scenarios where we need to define multiple functions with the same name and signature within the same file or translation unit (PU). This results in a name conflict, leading to a compiler error due to function redefinition. To understand this better, let's go through a small C++ program step by step, demonstrating this issue. First, we need to include the standard input-output library to use count for printing. So, we'll begin with #include iostream, and to avoid writing std count repeatedly, let's use the standard namespace with the piece of code. Using namespace std, now let's define a simple function void update. Inside this function, we'll print the message updating, void update, count, updating, endl. This function, when called, will simply print updating to the console. Now we need our main function, which is the entry point of every C++ program. Let's write it. Int main. Inside main, we'll first print calling update, and then call our update function, like count, calling update, endl, update, calling the function, and finally, we return 0 to indicate successful execution. With return 0, with the inclusion of int main, the program is now fully executable. Upon compilation and execution, the program simply print the two lines to the console. Calling update, updating. I recommend pausing the video here and verifying the correctness of the program using any C++ editor of your choice. I am using Visual Studio Code. Type it yourself and ensure everything compiles and runs as expected. This confirms that our function update is successfully being called from main and executing as expected. At the moment, there's no issue since we have only one function named update. However, imagine if another update function were defined elsewhere in our program or within an external library. This could lead to a naming conflict. So, what would happen if we had two different update functions within the same file? Let's explore the scenario by adding another definition of update in the same file and see the output. Now when we attempt to compile this code, the compiler generates a redefinition error due to multiple definitions of the update function within the same file. Here too, I encourage you to pause the video, type the code into an editor of your choice, compile it, and observe the error for yourself, just as I am doing on Visual Studio Code. Since C++ does not permit multiple functions with the same name and parameters in the same scope, the compiler flags the redefinition of void update error. As a result, the program fails to compile, preventing the creation of an executable file and producing no console output. An effective way to avoid conflicts caused by multiple functions with the same name in a single file is to use clear and unique identifiers for each function. Let's rename the first update function update function to graphics update and count update to updating graphics, and also rename the second update function the second update function to iUpdate. Similarly, you can create additional variations of the update function by assigning distinct names. For example, I'll also include physics update. Here, instead of naming all the functions with the same name update, we are giving each update function a unique name to avoid conflicts. With these changes, let's modify the int main function to call graphics update, iUpdate, and physics update. Let's compile the code and see how this works. Wow, this runs without any errors and prints exactly what we expected on the console. Alright, now I want you to pause the video once again, switch back to your favorite code editor, rename the update functions just like I did, compile the code, and see the output for yourself. In the original scenario, defining multiple update functions in the same file led to a compilation error due to duplicate function names. To resolve this, we assign distinct names, graphics update, iUpdate, and physics update. This prevents naming conflicts, allowing the compiler to differentiate between functions and compile the program successfully. While technically possible, giving all identifiers unique names in a large project is a recipe for disaster. It leads to a chaotic, unmanageable code base that is difficult to understand, maintain, and collaborate on. Share your alternative solutions below. I'll also be investigating another approach, which I'll cover in the next episode. If you're new, hit like, comment, share, and subscribe. Help us make more fun and gamified content.